a lesson itself, it will be more like a discussion, right? A discussion side. So if you got any questions, you got anything that you want to share, if you think teacher's method is not as good as yours, please also feel free to share in the chat. And so give me another 3 to 4 minutes. We will start later in 3 to 4 minutes. All right. While we are waiting, guys, if you are watching the live stream, how many of you have get this book, the all-in-one guide for almost gold? If you get the book, you can type maybe a 1, a yes in the chat. Yes, it is. We are going to go through the calculation topics in the book. I will go through all the the calculation topics in the book. There are 4 of them. Of course, I will go through some other concepts that is not really shown in the book. Right. Oh, a lot of you have got the book. Yes. Have you like tried the book by yourself? I think this year's book is quite nice, right? Actually, our teachers, the team have spent like about 1 month to make the videos and the questions in the book to make it nicer, more user friendly for you guys. If you don't have the book, maybe you can find some time, drop by our Tyson branch, and then go collect the book. Okay. Hey, how do I see the comment here? Oh, okay. A lot of people says yes. Great. You broke your leg. How can you go? Well, that's a pity. I'm not really sure. If you broke your leg, maybe you can contact our teacher, and we can reserve a book for you. All right. But yes, we do have limited amount of books. If you really have it, what do you mean by rip? Bro, it's not that. Bro, it's not died. He just broke his leg. All right. So by the way, guys, yes, we do have only limited number of books. So if you haven't collected yours, please find a time, go collect the book. Okay. Yes, like I said, if you don't have the book, you can drop by our Tyson branch and get some books. We still have a few left in the classroom. Okay, so why don't we just start today's go through session. We'll talk about the calculation. Okay, so to be honest, I can't say I'm very good at calculation. I made a lot of careless mistakes while doing the calculation. All right, so if you're confident in yourself and I says, well, I never make any kind of calculation mistake, I never make silly mistake while doing the calculation, probably you're already better than me. But for the calculation sessions, right? Actually, I like to start with something that is very basic. You all know the things that everybody knows, right? That is the 4 operations. Okay, so if I ask you this question, you might say, "Teacher is stupid." 4 operations everybody knows, even the P1 student knows, right? It's the plus, minus, times, divide, and maybe if we can also talk about the brackets, right? These are the very basic stuffs. Okay, so but guys, do you believe that I can make the basic stuff complicated and only use the basic stuff to make difficult questions? Anybody believe this? Well, actually, I'm not sure how many of you have checked the topic one, topic two, or topic three. You'll see that with only brackets and the four operations we have, actually we can make some difficult questions. Okay, but I don't really want to spend a lot of time talking about the difficult part. But my idea is whenever we see complicated things, let's bring it back to the things that is easy, right? The things that is easy. Now, with these four operations and the bracket, I think you all know these things called the board mass, right? So what is board mass? Board mass is the order of calculation, right? Pad mass. Okay, yes, you can say pad mass. All right, ball mass, parentheses or brackets. We have different ways of saying this. All right. Indeed, actually, for most of the calculation questions, they can be solved with these 6 letters and all the 4 operations directly. Okay, so we start with some easy ones. So, for example, right, if you take a look at the chapter 1, you'll see that we have a question that involves a lot of times, very, very long, a lot of brackets, right? So at this moment, some might get panic, but I guess without looking at the solutions, the very short solution at the bottom, how many of you says, "Oh, teacher, I can solve it without looking at the solution"? If you think you can solve it without looking at the solution, gives a thumbs up. Okay. Oh, of course you cannot give it a thumbs up. Okay. Maybe you can type a 1 in the chat, right? So actually, this is a very typical question that you can simply solve with the BODMAS. All right. So BODMAS, we know that we first come together with the brackets. Yeah, just cancel lah. Yes, indeed, we can just do the cancel. But some of you might get panic while seeing this. But what I want to say is don't get panic. Don't get panic, right? We start with the BODMAS, the B, which is solving whatever you have inside the bracket. So let's show everybody know how to calculate this one, right? This is half. How about the next one? 2/3. Next one, 3/4. So actually, if you continue in doing this, right, by simply using the BODMAS, the B, we're only using one letter, we already have a chain of fractions. Now, if you are in my class, not only in my class, in our P4 class, yes, a lot of people are sharing the answer to me, right? Actually, this is just cancel, so simple. All right, so we can just do some cancellation here. Cross out all the factors, numerators and denominators in the chain of fractions, and we only left with 1/100 times 2,000. Right? Seems like a quite easy lesson. So you see, like I said, with the BODMAS, even the most basic operations, we can already solve some seemingly complicated question. Right. So guys, if I want you to rate this question in a scale of 1 to 5, 1 for easy, 5 for difficult, what would you rate? Well, actually, I will simply rate this question. All right, I see a lot of ones in the chat. Yes, this is just a level 1 question, 0.5. Okay, makes sense. It's 0.5 question, right? You can solve it within 0.5 minutes, right? Okay, so this is the most basic stuff, the BODMAS. Now, in the calculation, there is also some tricks that can help us do the calculation faster and easier. No, why would somebody says 5? Okay, sure, you're just kidding, right? Okay, so there are also some tricks that help us do the calculation maybe a little bit faster. All right. So for example, the commutative property. Sorry, my writing is a little bit terrible. Commutative. Now, what does commutative means? For example, I can switch the calculation order between the division and multiplication, also addition and subtraction. All right, so that's saying, for example, if I have 18 times 200 divided by 36. Now, if you calculate directly, unfortunately, a bad news is that you have to calculate 18 times 200 first. But by simply swapping the order, all right, by swapping the order, you can get this one easier by doing maybe 18 divided by 36 first, and then times 200, right? Yes. So this is just one thing that actually most of you also have learned this in school, right? We can swap the order of doing calculation while we're calculating addition, subtraction, and times and divide. Now, there's another thing that is very, very useful in the upper primary, right? That's called the grouping. Actually, I would say grouping seems like it's nothing new. Nothing new. All right. So let me give you an example, okay? Okay, we have some people who rate from -1. Good. So let me give you an example. For example, let's say 2025 this year plus 2024 minus plus 2023 minus 22 minus 2021 minus 2020, and then plus 3 number minus 3 number plus 3 number minus 3 number, and then I go to the end, plus 3 plus 2 plus 1. Okay, guys, how do you calculate this one? So, sorry, I made a mistake here. Answer 100. How would you calculate this one? All right, so while we are calculating this, since we know that there exist some patterns here, right? So actually, we can try to group the numbers together to make our life easier, right? So how can we group the numbers together? Just group 6 of them together, since we know that we will definitely plus 3 minus 3. So we can group 6 of them together. Now, because they are 6 consecutive numbers, right? Sometimes every group will definitely give us a fixed sum, right? The fixed sum. Okay. So anybody would like to help me calculate what is the sum of all the 6 numbers inside one group? We already have people telling me how to do it. Good job. Always. Now, for some are telling me the arithmetic sequence, the Gaussian sum. Note that this is not exactly the Gaussian sum, even though the Gaussian sum is also about grouping, but this is not exactly about the Gaussian sum, right? I have 3 numbers plus 3 numbers minus. Yes, very good, right? So if you calculate it within a group, you can calculate like this. Difference between this is 3. Difference between this is again 3. Difference between this is again 3. Right? So actually that will be 9. Right? Inside every group, I do the grouping thing again, and it will give me a sum of 9. Okay, so all we need to do left is we need to find out how many groups are there. Right? We need to find out how many groups are there. So we have 2025 numbers, and every 6 numbers got a group. You'll see that this cannot be evenly divided because I have write it down the extra 3 terms at the back. That's 3, 2, 1. All right, but I'm sure that we have, this is 674, right? 674 groups with remaining 3 numbers. And 674 groups, every group, is it 600? No, I got tricked. I got tricked. All right, guys, you see, I do make silly mistakes. So can anybody help me? What is 2025 divided by 6? 2025 divided by 6 will be equals to? We're dividing by 6. Every group got 6. Answer 2027. Okay, I think this is 300 337 remainder 3. Okay, 337 remainder 3. Yes, thank you. All right, I thought, yes, 337 and a half, right? So that means we have 337 groups, and every group will give us a sum of 9, right? So 337 times 9, and then don't forget the remaining 3 numbers, which are here, 3, 2, 1, right? So we plus 3, plus 2, plus 1. And that will be the final answer. All right, thank you, guys. Now, since, as you can tell, I do make a lot of silly mistakes. Okay, so for the remaining calculation, I'll just stop here. I don't really trust myself. So, is how many of you actually at this moment now found this question? It's not that complicated. All right. If you think, after we do the grouping, you realize that this question is getting a little bit better than earlier. All right. Then once again, give me a thumbs up. Okay, and then we can talk, and then we can move on to maybe another technique that we have already mentioned here, which is 3039, right? Thank you. Which is another way of doing the pairing, the Gaussian sum. Okay. So actually, Gaussian sum is also doing the grouping. Guys, how do we do the grouping here? Who can help me a little bit? The most famous Gaussian sum, 1 plus 2 plus 3, all the way to 100. How did the great Gauss group the numbers together when calculating these sequence? Do it backward. Okay, do it backward. Very good. So actually, right, this is when Gauss do this is he reversed the sequence and then add the 2 sequence together, and then you'll realize that the two sequences are essentially the same, right? They're essentially the same, and so if we look at each pairs, they will give us the same sum, and of course we can just calculate how many such pairs are there and calculate the final answer. All right. Okay. Now this is, you can say, it's doing it as backwards, grouping as backwards. Right, it is very, very useful. Now, so I would like to give you another, maybe a slightly complicated question as an example. Okay, so the question, it goes like this. The question goes like this: 1 over 1 plus 1 square plus 1 over 1 plus 2 square, all the way to 1 over 1 plus all the way to 1 plus 10 square. Okay, now this is the first part. The second part would be 1 over 1 over 1 plus 1 over 1 square, plus 1 over 1 plus 1 over 2 square, plus 1 over 1 plus all the way to 1 over 10 square. Now this looks scary, right? This looks scary. But actually the idea would be very, very similar. How can we do it? Again, we do it backwardly. Now we pair up, not really backwardly, but we cut it into 2 parts and pair up the 2 parts together. 1 plus 1 over 1 square So if we pair up this together, all right, and then if we do some fraction calculations, you'll see that this is actually just 1 over 1 square. Right? Now, I'm not here to scare you, but for the next one, I will take one example question in the book to illustrate. I'm going to do that. Okay. Do the pairing. Okay, it's at, if you have the book, you can turn your book to page, you can turn your book to page, sorry, let me look for it. Oh, okay, never mind, it's not here. It's not here. Okay, so the book, there is, yeah, I know the last question is complicated. I know the last question is complicated. All right, I know the last question is complicated. You don't have to solve the last question. It's just sometimes whenever we get okay, I suddenly realized that we should start again, go back to the easier parts. Okay, so guys, let's come back to the easier parts. Let's come back to the easier parts. Right, let's come back to the easier parts where we were once again focusing on the grouping stuff. Okay, we're once again focusing on the grouping stuff. So so as we said here, right, the grouping, it's either you do it backwardly, or if whenever you find a pattern, you group them together. In a lot of cases, they will simplify the work for you, all right, and make a complicated question easier for you. Now, I'm thinking of another example, but before that, there is another thing that I would like to mention. That is together with the grouping, sometimes we also need to use something that's called a formula. All right, guys, for calculation formulas, anybody know any of the calculation formulas? Like the famous ones. Is there any famous ones? Go and give me a famous calculation formula that you know. A common and a famous calculation formula. No? Actually, we just mentioned one, right? The Gaussian sum is a calculation formula. What? Yes, should we have mentioned this one? It's n times n plus 1 bracket over 2, right? Okay. Square. Okay, yes, we also have the difference of square formula. Does anybody know what is the difference of square formula? The difference square is, for example, if we have a squared minus b squared, that would be same as, very good, all right, a minus b times a plus b. All right, this is called the difference of square formula. Now, there are a lot of ways to prove this. You can think about a square. Let me just give you an example of specific numbers. Okay, so for example, 10 squared minus 5 squared. Now this will be equals to 10 minus 5 times 10 plus 5. Okay. And the area of triangle, well, that is not really the calculation formulas. Right? But let's first of all stick with this difference of square. Now the proof of this is you can draw a big square, let's say a big square with a side length of 10, right? Yeah, you all know this is 75. And then you take away a smaller square that has a side length of 5. Now the difference of square is actually, you see, 10 square is just the area of the big square, while the Well, the 5 square is the difference of the area of the small one, right? So if I'm looking for the difference of 10 square minus 5 square, it's actually asking for the area of this part, right? So how can I calculate the area of this part? It's an L shape. It's irregular. So we turn this figure into a regular figure by cutting in here and move it to here, right? So once you do this, you'll realize that our final figure is just the area of rectangle. And I saw somebody is texting in the chat says the area of the rectangle is breadth times the height. So you see the breadth is 5, while the length is 10 plus 5. Right? So that's how we can prove our difference of square formula. That the difference of square is just the product of difference of two numbers and the sum of the two numbers, right? So formula is also very important. Now, there are more formulas than this, right? You might have not learned this. For example, 1 square plus 2 square plus 3 square plus all the way to n square. The sum of the squares, right? It also have a formula which is 1/6 times 1/6 times sorry. All right, the sum of the square formula is 1/6 times n times 2, sorry, m times n plus 1 times 2n times 2n plus 1. Okay? I think if I remember correctly, okay, of course, I'm not very good at remembering the formulas. Please point it out if I remember incorrectly. But the proof of this is, well, just I'm not going to talk about this here as it's a bit too far above what we're going to do today. Okay, and we also have 1 cube plus 2 cube plus 3 cube plus n cube. Right, and the formula of this is the sum of all the n numbers raised to the power of 2. Okay, so there are a lot of different formulas while we're doing the calculation. But for you guys, if you are going for NMOS, I would say these two formula is enough and also necessary for you. All right. Well, the square root formula, the square root, yes, we do have the square root, but that's for secondary school students. Right. So, guys, if you don't know these two formula, at least get yourself to know these two formula. And next, we will take a look at a question that indeed will need the square root formula. All right, yes, I will try to go a bit slower. All right, I'll try to go a bit slower. So, guys, let's take a look at this example 2. Okay. Now it looks even more scary. All right, it looks even more scary than the earlier one. But you know what? Our bot mass still follows. Whenever you see this, all right, whenever you see this, guys, we got a lot of brackets, a lot of fractions. Answer is 4040, yeah. Yes, definitely you can see the answer. All right. I see a lot of people says IDK. I don't know. But just let's follow my step. We can think about how to solve this. Okay. So we can still follow what we just did, which is the bracket, the B. We start with the letter B. All right. So let's, for example, take a look at one of the bracket. The first one. 1 minus 4/3 squared. Now, if you were me, guys, if you were me, how would you how would you calculate this one? How would you calculate 1 minus 4 over 3 squared? This is actually a fraction calculation. Right? Why are you all texting the answer 1717? So for the fraction calculation, we can first of all make sure that when you do the calculation. Okay, I should write it down a little bit. Sorry. If you can't see the top, I'll write it down a little bit. All right. So the first bracket is we can write it as, first of all, 3 squared over 3 squared, right? So when you do the subtraction, you change into the same denominator and then do the subtraction. So this is actually 3 squared minus 4 over 3 squared. But actually, whenever you see this square thing, right, you should think about our difference of square formula. So what's the difference of square formula? That is, first of all, you must have difference of 2 squares. But here we only have 1 square. Where is the another square? Where's the another square? The another square, some of you are already typing in the chat box, says 2 square is 2, right? So actually we can write as 3 square minus 2 square over 3 square. Sorry, the top just says the bottom is. Okay, and then our numerator, you can now try to apply our difference of square formula, right? So 3 square minus 2 square will just be 3 minus 2, which is 1, times 3 plus 2, that will be 5, and over 3 square. So the first term, we have successfully changed into 1 times 5 over 3 square. All right. All right, 1 times 5 over 3 square. Now, if you are still a little bit confused, right, we can actually move on and try another one. Next one. 1 minus 4 over 4 squared. How do you calculate this? We have a fraction. So we change into same denominator. All right. Guys, let's just try to catch up step by step. We're just doing fraction calculation, nothing special. All right. So 4 square over 4 square minus 4 over 4 square. But it's same. Now we can still write the 4 as 2 square. Right? So we just rewrite this as, well, 4 square minus 2 square over 4 square. And just now I have talked about the difference of square formula. So guys, what is 4 square minus 2 square? 4 square minus 2 square will just be 4 minus 2 times 4 plus 2 over the same denominator, 4 square, right? So this is just 2 times 6 over 4 square. Yes. Okay. So you see, step by step, I'm not doing anything that is special, right? Why can't you just take out the square root at the front and then change it into 3 times 9? Yes, I mean, if you want, you can do, but it will be the same thing. It will be the same thing. And actually, by doing this, you'll see that later I can do some further cancellation and then make our number much smaller. Okay? So based on what I just did, I have now changed equation to 9900 times the first term, 1 times 5 over 3 squared, times the second term, 2 times 6 over 4 squared. Now, anybody would like to have a guess? What would be the next term? I'm telling you that there is some patterns over here. There is some patterns over here. Just by following the pattern, right? What would be the next term? Now you don't have to really necessarily calculate it out at the moment. It will be 3 times 7, right? It will be 3 times 7 by doing a run of guessing. Why guessing? You see, 1. Look at the first number. It's now 1, 2, 3. The second number, 5, 6, 7. Right? What a nice thing to have. So what would be the next one? What would be the next one? What over 6 squared? What number over 6 squared? Sorry, let me recharge my laptop. Look at the pattern. 1, 2, 3, 5, 6, 7. So the next one will be 4 times 8. Yes, 4 times 8. All right, so it's 4 times 8 over 6 squared. All right, now you have all get the pattern here. So let's skip the remaining. Jump directly to 100 square. Now, what will be over the 100 square? What will be over the 100 square? If you keep following the pattern, let's see how many of you can get this one. If you keep following the pattern, what will be over the 100 square? 32? Of course, you can take a break, everyone. Right, yes, very good. We have a lot of people get it already. That will be 98 times 102. Okay, 98 and 102. Right? So this is the sequence now we have. Now we can try to do some cancellation. Why we can do cancellation? Because as long as you see the same number in the numerator and the denominator, you can always do the cancellation, right? But actually, we can rearrange this by a little bit to make it easier for us to see. Okay, so how can we make it easier for us to see? You see, the first term in the numerator is always 1, 2, 3, 4, right? So let's write it like this. 9900 times a very, very long fraction chain. 1 times 2 times 3 times 4, all the way to 98. Now this will be all the first term in our numerator. All right, this will be all the first term in our numerator. I'm just multiplying the fractions together. I'm not doing anything special, right? Okay, so the second group we can do is take a look at the second term in the numerator. So that will be 5, 6, 7, 8, 9, all the way to 102. All right. And what do we have in our denominator? We have 3 squared times 4 squared times 100 squared, which I will rewrite them into two groups of 3 times 4 times all the way to 100, and another group of 3 times 4 times all the way to 100. Now let's see, anything we can cancel here. There are quite a lot of things we can do the cancellation, right? 3, 4, actually 3, 4 all the way to 98, we can all cancel out. So for the front part, we only have left with 99 times 100. All right, as long as you see same number, you can just cross them out. As long as you see same number, you just cross them out. All right, and now for the second part, I don't have the 5 and 6, but I do have, oh, sorry, I don't have the 3 and 4 in the numerator, but I can start with 5 and 6. I can do the cross, all right? I cross out all of them until the 100. Now, in the numerator, I'm only left with 101 and 102, where I cannot find it in the denominator. Right? So now let's see, what do we have in the numerator and denominator? What do we left in the numerator and the denominator? Okay. So I ignore the 9900 because I haven't really used it anyway. I have, let's see what remains behind. We have 99, 100, 3, 4. These are not crossed out, right? So I write it down, 99, 100, 3, and 4. Denominator, I copy done. And in the numerator, let's see what do we have left. 1 and 2, I never crossed it out. 101 and 102, I never crossed it out, right? So for the things I never crossed it out, I can keep them here. 1 times 2 times 101 times 102. Okay. So with a bunch of cancellation, now I only left with this. Now I only left with this. So what will be the final answer? Actually, it's already here. Right? Actually, it's already here. Okay. So relax. I know that this is a little bit fast. I know that this is definitely a little bit fast. Right. So next time if you are doing this by yourself, I want you to do this step by step. Okay. Of course, I'm doing this a little bit fast. Yes, we can cross out the 99 and 100 because this is exactly 9900. All right, so that's why we can cross out this, and we only left with 1 times 2 times 101 times 102 divided by 3 divided by 4. And then you can just calculate to get the final answer, 1717. Okay? Okay, so this is about the calculation, the formula that we probably can use. And do not spam the chat box. I can tell that a lot of you have your brain exploded. Guys, I'm not intended to kill your brain cells. I'm really not intended to kill your brain cells. All right. But for the actual work, you can do it afterwards. After all, we do have the playback. Rewatch the playback, right? And do this step by step. Really try it by yourself. Okay. Easy. Okay. Now, guys, if I ask you to rate this question with a scale of 1 to 5, what would you rate? If I ask you to rate this question with 1 to 5. Some people says easy peasy. No, 1 to 5. How can it be 6? Okay. Some says 1, some says 4. I mean, maybe between 2 and 3. 3 maybe. Okay. Okay. Guys, 3.9. All right, I see a lot of people got their mind exploded typing a 10-digit number rating. All right. So this is what we can have. Yeah, the only difficult thing is calculation. All right. So now you see, don't get scared. Don't get scared. We're still starting with the BODMAS, right? We're still starting with the BODMAS. Okay. Now, let's forget about the fractions. I think a lot of you were tired doing that. Let's move on to the fun part, which is the new operations. Now, actually, new operation is guys, do not spam the chat box. All right, do not spam the chat box, please. Okay, so the new operation is more like what? All you need to do is to understand what is the question talking about, right? It's really defining a new game rule. Now, every time when you play the game, whenever you are playing a new game, the very first thing you should do is you understand what is this game about, right? You must have a clear understanding of what is the game rule here, right? Otherwise, I can't even imagine how can you play the game, right? So new operation is doing the same thing. It's literally defining a new thing. Yes, a lot of you might have done with this chapter, right? It's literally defining a new thing for us to use. Actually, I can define one by myself. I love cats. So let's say I now define a new operation cat. Okay, this lonely cat. Now, what does this cat do is I define an easy one. All right. So let's say A cat B will A cat B will now be equal to A square plus B. Okay, it's just a random new operation cat. I call it a cat. So with this new operation, actually the rule here is not that complicated, right? So if I give you two specific numbers, let's say 2 cat 5. So what will be the answer of 2 cat 5? What's that? Yeah, the 2 cat 5 will be a 9. All right. That will be 2 squared plus a 5. Okay, so that's a 9. Okay, so I guess this is not that bad, right? This is not that bad. All right. Give the cat a friend. All right. That answer is 9. Sure. So like I said, the main idea is we understand the game rule, right? So if you look at the example here, the game rule is not that difficult. Right? The game rule is not that difficult. It's just we have a star. It's just the first number times 5 plus the second number times 3. Right? So if A star 9 equal to 37, now what is the value of this? Now, whenever we talk about the new operation, the BODMAS, I feels like I'm talking about the BODMAS for a lot of times already. Right? The BODMAS is still applies. The BODMAS still applies. Right? So you still have the order of calculation. If it's not specified, we still have the order of the calculation. Right? Now a lot of me text me the answer. Yes, I know the answer. You all know the answer if you have the book. Just turn to the next page, you'll see the book, you'll see the answer. Right? But listen, why? How can we get this? Actually, sometimes just use some algebra to help you out, and you'll easily solve this one. Right? So follow the game rule. This one we can have 5 times the first number plus 3 times the second number. Now we know that this is equal to 37. Okay. So what is the value of the A? The value of A will just be, with the value of A, 5A. Let me write one more step. 27 equal to 37, right? A will just be 2. Okay. So 5A equal to 10 and A equals to 2. Oh, sorry. While I'm writing 2, while I'm saying 2, I wrote down 5. Okay, it's just 2 here. Right. Okay. Now all we need to do is we replace the A here with a 2, right? And then, yes, I know it's easy peasy. And then you follow the game rule, you calculate with the fractions. Again, don't forget the BODMAS. If it never specified, follow the BODMAS, right? Okay, so this would be a really, really, yes, easy peasy question, right? Okay, so for the remaining part, if you're confused about how to do the actual calculation, let's just take a look at the solution at the next page. Okay. So the new operations is most of the questions of new operations are not really complicated, but there are some that confuse people. Some confuses people. So I will go directly to not this question. This question over here. Okay. So everybody, you can now turn your book to page 16 if you do have the challenge question 1, where I'll be talking about some special numbers. Some special numbers in the new operation. Okay. So if you take a look at this question, I'm not sure how many of you have done this one before, all right? So who've done this one before? I guess, give me some actual response. Who've done this one before? If done this one, type a yes. Oh, we already have people says easy. Okay, a lot of you have done this one. So this is actually about the special number in the new definition. Isn't? Okay. So if you look at this new definition, this time the star seems very complicated, right? So if you want to calculate one by one, teacher just said we follow the BODMAS, so we must start with the 1 star 2. But you know what's gonna happen? You know what's gonna happen? If we try 1 star 2, right? If we try 1 star 2, you'll die immediately. Okay? If you try 1 star 2 and then star 3, you'll die immediately. Your brain will explode it immediately. Let me show you what is going on if we try 1 star 2 directly. That'll be 1 times 2 plus 16 over 1 plus 2 square, right? I'm just replacing the AB with the numbers. But then what do I get? I get 18 over 3 square. Okay, still fine at this moment. 6. All right, 6 square, which is 36. So the first bracket give us 36, still fine. But then if you try 36 star 3, all right, guys, I'm not gonna do this. I'm not gonna do this. Okay, my brains are just too small doing this. 36 star 3. This is definitely gonna kill me. Okay, so Any good ways to do this? Now here we need to talk about some special number. Okay. Now this operation is talking about square. And in the definition, it has a specific number 16 that is given. So guys, if I give you number 16, I tell you something square. What would you think about? What would you think about? 16 is actually a what square? 16 is actually a what square? Sixteen is actually a 4 square, right? 16 is actually a 4 square. Okay, so that is saying whenever you are given a specific number in the definition, sometimes, right, you will get special number that is related to the specific number that is given. So the special number in this question will neither be 4, 16, or 16 squared, right? But since our calculation have nothing to do with 16 and 16 squared, we only have the 4 here. So most likely that will be saying 4 will be the special number. Okay, so let's just do an experiment. Okay, guys, you can type a big number in the chat. Give me a big number. I'll use the big number to star 4 in this example. Okay, any kind of big number, just don't be too big. I don't want to write too many digits. Give me any kind of big number. That will work. No, guys, that would be too big. I can't write this many digits. Maybe a slightly smaller ones. Okay, let's take 9999. All right, let's take 9999. Okay, so let's see what happens when we use 9999 to star 4. Okay, 9999 star 4. So according to what we have, right, this will be equals to 9999 times 4 plus 16, right, over 9999 plus 4. Okay, seems like not good at all. Why would this be useful? Now, guys, just now we said what? We said 16 is 4 times 4, right? 16 itself is 4 times 4. So 4 times 4. Okay, and then look at here. What do we have? We have the 4 in both terms. Okay, so whenever we have 4 in both terms, we can take out the 4 and leave everything else behind inside a bracket, right? So we can take it out. We leave as 4 times 9999 plus 4. Now the numerator is still the same, right? And then denominator 9999 plus 4. Now what do you notice? Now what do you notice? You notice that we finally get a same thing. I guess that'll be good enough. Stop texting the long numbers. That'll be good enough. Okay. So if I have 9999 plus 4 in the numerator and denominator, what does that mean? That is telling me that, right? So all it remains is just a 4. So this example is saying what? No matter which number star 4 calculate with 4, our final answer will always be 4. So actually, I don't even need to calculate here anymore. I can just leave my answer as 4, right? So this is the special number type of question in NMOS. Now, of course, if you scan the QR code, you'll see another 2 questions related to the special number. Okay, so maybe next time while you are doing the practice, the challenge practice questions over here, Now maybe you can find some special number to help you a little bit. Okay. All right. So this would be the shocking, right? Shocking. Okay. So this would be um the new definition part. Okay. New definition part. All right. So let's move on to the next part, which will be sequence and number tables. The sequence and number tables is all about one word, pattern. Am I spelling correctly? Yeah, four square. It should be a square here. I realized that I forgot the square thing. All right, so I forgot the square thing. Guys, I'm sorry. I realized I forgot the square thing. All right, so now let's take a look at the topic three, which is about the pattern. Okay, pattern. So the pattern and the number sequence, there also there's some special things that you can try to remember. All right, but the basic number table questions, it's actually just find a pattern. But guys, when we find a pattern, what is important is we need to find out the cycle. We need to find out the group. Right? We need to find out where is the repeating group in our number table. Where is our repeating group? Right? So that you can do the calculation easily. Right? So for example, this question, how many numbers in a repeating group? Actually, everybody can see on my screen that we have 8 numbers in a group. All right, 8 numbers in a group. So these 8 numbers will be in a group. These 8 numbers were in a group. So if you're asking where is the 2019 number, right? Of course, just divide by 8 first. Right, just divide by 8 first. Okay, so this is finding the group. Now, I would say this is the basic type of number tables. So if you look at the practice question, also similar, right? Just find out where is the cycling here, where are the repeating groups. Now, if you're looking for 2111, we know that. Again, you can take 6 numbers as a repeating group and then use 2111 divided by 6. Of course, works. Or right. So for all of these types, it's just find out the repeating group, and then you'll be able to solve them by yourself. And then you'll be able to solve them by yourself. Okay. So this is the basic type. Now, of course, the more advanced type that is, sorry, I'm gonna skip this. A pyramid, right? A pyramid. So, I feel like I haven't asked you to rate the question for a long time already. I forgot to do this. But guys, let's do the rating again before we move on. Before we move on. Um, this is I'm not really sure. The class may end in maybe another 30 or 40 minutes. All right. So for the last new operation question, from 1 to 5. What will be your rate? Last new operation question. The square. Now today will not be 2 hours. I think it will be shorter than 2 hours. The last new operation questions, guys, from 1 to 5. What do you think? 2, 5. Okay. All right. So now let's actually move on. All right. Let's actually move on. All right. Stop spamming the chat box. So the next question would be, what if we get a pyramid like number table, right? Now this is hard to find a pattern, right? But actually we still have the pattern. Now we have 1 number, 3 number, 5 number, 7 number in order, right? In order. So if you want to know which row does the 2015 appear in, now what should we do? We should know, right? First of all, since all of them are the odd numbers, we should first know 2015 is which odd number? 2015 is which odd number? 2n minus 1. 2n minus 1 is the 2015. So 2015 is which odd number? Plus 1 divided by 2. Very good. So it will be 2015 plus 1 over 2. 1008. Okay. 1008. All right. So that means we are looking for the 1008th number in the number table. How can we find out the 1008th number? Well, let's say, what are the numbers in the first row? It's the first number. Second row is the 1 plus 3, right? Numbers in the first fourth term. Third number is 1 plus 3 plus 5, the number in the first ninth term, right? But actually, it keep doing this. Guys, what do you notice? 1 plus 3, that will be 4. 1 plus 3 plus 4 plus 5, that will be 9. And then 16. Look at how many numbers do. What is so common about these numbers? Guys, what is so common about these numbers? 1, 4, 9, 16. And actually, if I add another row, the next row will have 9 numbers. The next row will have 9 numbers. So the next, in total, you will have 1 plus 3 plus 5 plus 7 plus 9. That's 25 numbers. Guys, what do we know about all these numbers? They are squares, right? So actually, this is saying, okay, up to nth row, there will be in total n square numbers in it. N square numbers in it, right? You see, first row, in total, I have one square, sorry. In total, I have one square number. And the second row, in total, I have 2 square number. Third row, I have 3 square number. Fourth row, I have 4 square number. Fifth row, in total, I have 5 square number. All right, so nth row, in total, we have n square number. Now, we're looking for the 1008th number. Where is the 1008th number? So all we need to do is to find out which square number is slightly bigger than 1008. Right? Which square number is slightly bigger than 1008? And actually, you can take note of this. Now the answer will be 32 square. Okay, I can't really remember what is 32 square, but I think the answer it might be here. Yes. 63 square is a little bit big. Actually, if you want to remember some square numbers, I highly recommend you to remember the 31 square and the 32 square. Right? Because they are the closest square number to 1000. Okay? So the final answer of this one would just be 32. Yeah, second row, now there are 3 numbers, but I'm talking about in total. So the first row and the second row together have 4 numbers. The first row and the second row and the third row together, they have 9 numbers. The third row, second row, third row, fourth row, the first 4 rows together, they have 16 numbers. I'm always talking about in total up to nth row, how many numbers do we have? Okay. Yes, indeed. Talking about the square numbers. Talking about the square numbers, guys, do you know that 2025, this year number is also a square number? What is the root of 2025? What is the root of 2025? 4. 45. Yes, that will be 45. Okay. So it would be great, since this year is the year 2025, it would be great to remember this. Now the 2025 is 45 times 45. Right? It's 45 times 45. Okay, so this is about the number table, right? So yes, you can look for some special numbers. And actually, if you can master all the questions in the front, and if you have tried this question, the challenge question 2, you can also find out some square numbers to help you identify the special location. Take a look at where are the special square numbers. 1, 9, 25. I can even guess that next one will be 7 square over here. And also we have 4, 16, right? 2 square, 4 square. So the 6 square will be here, right? So whenever you see square number table, then they are going like this. Okay. Then the square number is the one that you should look for. Well, when people say I use the calculator, yes, actually, calculator is the most important thing I used while doing the calculation. But at least this year is 2025, right? At least try your best to remember this one number, 45 square. Okay. Okay, so this will be about the number table. Now, next topic will kill a lot of people. Actually, I was hesitating when I'm making the next topic. I was telling like everybody, you can skip the next topic first. The quadratic equation. I mean, for most of the primary students, okay, do skip this topic first. After you can do all 29 other topics easily, then come back to here. Right. Then come back to here. After you can do all another 29 easily, and then you come back to here. So this is literally a secondary school topic. All right, then you might wonder, teacher, why are you putting the secondary school contents in the book? Well, I have to. After all, NUSH are looking for students who can do well in the secondary school maths, right? So, so don't be scared by this topic 4. Okay, it's okay that you don't get the quadratic equations over here, but I would say for you guys, quadratic equation is guess. This is the only important method that you should know for the quadratic equation. Guess an answer. I guess an answer. So for example, here, x squared minus 4x plus 3. Now, if this is equal to 0, Of course, if you know the formula, right, I can tell that surely is sending out the formula in the chat box. If you know the formula, use the formula. If you don't know, guess an answer. All right. How can you guess an answer? Now, here is the tip. The answer in most of the cases will be a factor of this number, what we call the constant number. Okay. It will be factor of a constant number. So for this equation, right, I think the answer is just 1, which is a factor of 3, and also 3, which is also a factor of 3. All right. So for you guys, I would say just guess the answer. Just guess the answer. Super, super useful. Okay. So of course, you can look at another questions over here. For example, here, x squared minus x minus 6. All right. Also, equal to 0. Guess the answer. Guys, what would the answer that you can guess here? Yes, only P5 are allowed. Unfortunately, NMOS is only for P5 kids, but they do test this. That's why I'm teaching you to guess the answer. Right? Okay, we have people guess the answer of 6. So let's try 6. Right? 6 squared minus 6 minus 6. Well, it seems like no, a little bit too big. Maybe have another guess. Give me another guess. Like I said, it would be most likely to be a factor of 6. All right, let's go for 3. 3 squared minus 3 minus 6. Does that work? It works. Okay, so the answer will be 3, right? So, like I said, for you guys, if you can understand what am I writing here, understand it, read and try. Right? If you don't understand, just have a guess. It will be definitely be a factor of this number. Okay. It's 3, guys. It's 3, right? So if we take a look at, I guys, don't blame me, because actually the NMOS is actually testing about the quadratic equations. I don't want to do this, but it's actually testing about this. So unfortunately, you have to know how to guess the answer, right? So here, this example, I use this question as an example to show you how to guess an answer for this type of question. Okay, you see, it's a special run, so it's already like one of the most difficult questions and most. But later, I'll ask you to rate again how difficult is this question. Okay, so here we are already given an equation, right? It says we give it a number n. The dragon was shot back. The dragon was shot back this number, and difference is only 2. Yes, this is, as you can see, this is a real competition question. I'm taking a real question here. All right. So this is saying that we can have write down the equation of this. Minus n. This is the number that the dragon shot back to me. And I know that the difference between this question and my number n will only be 2. Right? Actually, it will not be only like this. It's neither n plus 2 or m minus 2. Now, this is called the difference of 2. Yes, the answer, it is 14. But let's see, how can we do this? Ain't no way dragons know math. No, nowadays, dragons must learn math, unfortunately. All right, so whenever you do this, remove the bracket. All right, we'll come back to our calculation, most basic stuff, the bot ones. Okay, remove the bracket. To save some time, I will not spend a lot of time on this, right? So I'll just use the conclusion we have here after simplification, okay? After simplification, we'll have this. Of course, I'm skipping this does not mean that you can skip this. While you are reading through the question over here, do it by yourself. Okay, do it by yourself. Okay. So so let's take a look at this two equation over here. All right. Now, like I said, whenever you get an equation like this, right, you don't know how to solve, guess an answer. Guys, really, guess an answer. So let's start with m squared minus 28m plus 192 equal to 0. Let's see how many of you can guess an answer for this one. Remember what did I said? I said the answer will definitely be a factor of the constant number. Now, of course, this raised some confusions. Right, so guess the answer first. 14, right? So is this a multiple of 14? This is indeed a multiple of 14. So let's try 14 squared minus 28 times 14 plus 192. Guys, does this work? No, this ain't a square of 14. This is a multiple of 12. So should try 12. 12 squared minus 28 times 12 plus 122. Does this work? Does this work? A 2, 4. You can tell that 2 and 4 may be a little bit too small, right? So, I mean, the number here is kind of big. Of course, it will take you a lot of time to guess an answer. But I think if you try 12, this will give you an answer. Okay. Well, you know what? I'll show you another way to do this. I'll show you another way to do this. Okay. So instead of considering this equation, guys, let's follow my step. We can rewrite the equation as 192 equals to 28m minus m squared. Right? 28m minus m squared. And then, since they both terms have an m, I can write it as 28 minus m times m. So what does that mean? That means my 192 can be written as a number times 28 minus a number, minus this number. Okay, now once again, have a guess. How can we do this? Do the prime factorization of 192, right? And then again, try the factors of 192 and find out the answer over here. Okay. So like I said, for these type of question, it is okay that you guys don't know how to solve, right? Whenever you see this in the actual competition, right? If you are really P5 this year, whenever you see this in the actual competition, guys, just skip the question. Skip the question. Y'all know how to skip the question, right? So just skip the question, right? All right. So this is the example question. Now, for the remainings, hopefully you can try do it by yourself. But you know what? You know what? Let's just do another practice together, okay? And to see how many of you can guess the answer correctly. X squared minus 14x plus 24 equal to 0. Okay, anybody would like to have a guess of this one? If you know how to do, solve it, solve it, do it, just solve it, right? I'm saying if you don't know how to do, well, we have a guess set 6. Okay, let's have a guess 6. 6 squared minus 14 times 6 plus 24. Guys, does this one works? Does this one works? It seems like no, right? Okay, you see 6 squared, it seems like it's a little bit too small, right? Um, yeah, why don't we just try 12? Maybe we can try 12. 12 squared minus 14 times 12 plus 24. Guys, does this works? And this indeed works. And this indeed works. So the answer is 12. Hey, don't just randomly guess the answer. When you guess the answer, guess the factor of a constant. Okay? Guess a factor of this. Oh, okay. What about 0? Does 0 works? No, 0 doesn't really works. Okay? Guys, this would be the answer. Yes, actually, if you try 2, 2 is another answer. Right? If you try 2, 2 is another answer. 2 squared minus 14 times 2 plus 24 also equal to 0. Well done. Okay? 2 is also an answer. So this is how you can get an answer for this question. Right? Like I said, do the guess factor of this. Okay. Of course, if you can understand the topic, try to read the topic, and hopefully you can solve the quadratic equations later. I would say today we are running a bit short to run through about the calculation. If you want to try 8, right? 8 squared minus 14 times 8 plus 24. I think this is a little bit too small. 8 doesn't really work. Right? This will give you a negative number. So probably it doesn't really work. Okay. All right. So for those who still need to work on the other topics, please skip the topic 4 first. All right, skip the topic 4 first. All right, so for the calculation, that'll be all we have. That'll be all we have. Actually, NMOS will not test very complicated calculation questions. Oh, guys, let me do another survey. How many of you are going to take the IMO this year? How many of you are going to take the IMO? Well, if you are taking IMO, let's type a 1. If you are taking MOs, let's type a 2. Okay, let's see how many of you are taking IMO or MOs. Well, if you're taking IMO, unfortunately, you have to know a bit more in the calculation. The the calculation module in IMO is quite difficult. There are a lot of different type of questions that you have to master before you take in the IMO. All right. So if you are starting with us, make sure that you do some mock test, make sure that you do some past year paper, and ask your teacher how to handle the calculation modules. Okay, it is rather important, and it is the type of question that can be improved very rapidly within 1 week or two. Okay. Well, a lot of people taking 1 and 2. Wow, I would say good luck, guys. If you're taking 1 and 2, then I guess you're all P5 students. I mean, not a lot of P5 students were invited to attend the IMO. Well, that means you are already very good students. But if you are P6, Yes, APMOPS also. APMOPS also. But this one have the most difficult calculation. All right. So you know what? Today, after all, I only have 1.5 hours. I know a lot of you are blaming me for killing your brain cells. Guys, I'm not intentionally to kill your brain cells. But you see, if you have further questions, you can either go ask your teacher, right? Or you see, we do have a lot of groups for you to discuss and share your thoughts with your teachers. Yes, and I will also be being very active in the groups, answering all your questions. Okay, so guys, if you do have a lot of questions while walking through this paper, while walking through this book, do not hesitate to send your questions and to send your questions in the group chat. Okay, all right. Now NMOS and APMOPS, they are not exactly the same. This is by NUSH, but this is HCI. This is Huachun. All right. All right. So and this is for II. So yeah, like I said, don't have to worry about if you are P4, don't have to worry about these at this moment. You still have a lot of time. If you are P5, guys, really, and take some time to at least go through the topics we have. Okay, and I would say that's more or less the end of today's calculation module, as the next module will be about the number theory, which I'm sure will kill more brain cells tomorrow. All right, so yes, so go refresh your brains a little bit, and get your brain cells prepared. I will definitely kill more brain cells tomorrow. All right, and guys, if you think, how about this? Let's do one last run of voting before we end today's session. That is from 1 to 5. Okay. How hard do you think the NMOS calculation module is? From 1 to 5, how hard you think the NMOS calculation module is? 3, 5. All right. If we ignore the quadratic part, I would say it's maybe more or less like 3, moderate level. It's just a moderate level. Okay. All right. Okay. Everybody's saying 5. Okay, I'll take it. I'll take it as a 5. Yeah, 3 to 4, 3 to 4. For most of the P5 students, after some work, guys, let's try your best. Try your best to lower the difficulty level for you, to maybe 3 to 4. Okay, that would be good. All right, so guys, that will be end of our calculation run throughs. We only have 4 calculation lessons, so today will be slightly shorter than the remaining ones. But of course, right, if you have anything that you want to discuss, if you have anything that you want to say, you can stay here and ask me. Um, if you don't have another questions, then I'll probably just see you tomorrow at the same time, 2 p.m. Okay? Yeah, bye y'all. I really want to see you maybe tomorrow once again. Okay? For the number series. Bye bye. No, this today will just end here. Okay, bye bye guys. Bye bye. Forget to don't forget to make an appointment in your calendar. You can click the appointment button in the YouTube or WeChat. Make sure that if you have time, you can attend our run through for number theory tomorrow at the same time, 2 p.m. Okay. Bye guys. Bye. Okay. Okay. Bye bye bye. Yes. Number theory is which topic? If I show you this, the number theory will be and from topic 18 all the way to topic 21. Okay, all of these are these 4 topics. Yes. Okay, so if you got time, yes, that would be great if you can read through the concepts we have in these 4 topics. They're quite heavy. Uh, they're quite heavy. Hey, but also very, very important topic. All right, guys, if you don't have any other questions, I guess our the calculation live stream will just end here. And don't forget to come back here tomorrow at the same time about 2 p.m. and we'll go through more interesting stuff, the number theory. Okay.